So let's take a look at solving equations.
I think this flew.
So as we start solving equations for exponential and log stuff, you basically just have to remember how you undo things. And as we go back to thinking about how you undo stuff, that goes back to the idea of some of the basic properties. Log base b of b to the x is x, and then b to the log base b of x is also x. If you go and use these two properties, that's how you're going to be able to undo logarithms, undo exponents, things like that. To undo a natural log, you would e it. To undo e, you would natural log it, and so on. So there's a lot of these little things that will happen. Excuse me. What I want to look at, though, is more or less today just to kind of start with some of the equations without getting into the real nasty stuff where you have to use all the properties to put them together to figure out where you're going with them. So we'll start out slow and then just kind of build into it. Now, excuse me. As we go into the equation stuff, the way that they always start these things is, like I said, really, really, really easy. They don't try to mess with you too much. One way that you can get up and solve these equations is if you notice when you have exponential equations where the variables in the exponent, what you want to do is try to create a common base. Okay. So one of the ways that you could create common bases is to rewrite the 4, rewrite the 8, because one of the properties that happens is that if you have common bases, your exponents are equal. So if you're able to create a common base, then the exponents will fall. So if you look at the 4 and the 8, what would their common base be? 2. How can you, because you can rewrite 4 as 2 squared. 8 can be rewritten as 2 cubed. So what we're going to do is rewrite it. It's 2 and you get that. At this point, you'll see that you have the same base on both sides. Once you have the same base on both sides, your exponents can fall. Okay? One of the ways that we can do that is we could take the log base 2 of both sides, or just knowing that the rule is when you have common bases, the exponents have to be equal. So this just means that you get 6x equals 3x plus 3. Solve for x. And you get 1. Okay. Now, once again, with these exponents and stuff like that, always take a second, go back and double check it. The math here is really easy, plus you're using a calculator 9 times out of 10 anyway. What's 3 times 1? 3. What is 4 cubed? Oh, how about this? What's 4 squared? 16 times 4. 64. What's 1 plus 1? What's 8 squared? Did it work? There it goes. Okay. Not too fancy. Let's try another one. Do that one. Okay? So you rewrite it as have a common base, so you get 3 squared times 2x is 3 to the x minus 6. Do you have the same bases now? Yeah. Exponents then fall. You get 4x is x minus 6. You get negative 2. Okay? Now, that means if I substitute in, I get 9 to the negative 4. Does that equal 3 to the negative, what is that then? Negative 8? It should. Yeah.
It does.
It should, because then if you look at the exponent rules, you can rewrite 9 again as a common base 3. 3 to the negative 8 equals 3 to the negative 8. So it does work. Okay. That will work. Not too fancy quite yet, right? Not yet. Okay?
Please don't make it hard yet.
2 to the x equals 7. 2 to the x equals 7. Now, what you need to think about here is, you have, sorry, that exponent didn't turn out really well. If you start thinking about that, how do you get that exponent to fall? What property do you need to do to both sides to get the exponent to drop? I can't take a square root of it. Square root won't work. Think about your log property. Nope. Think about your properties. When you have properties of logarithms, how do you get an exponent to drop? Well, you've got log base b of b to the x equals x, and b to the log base b of x also equals x. Which one of those two makes the x as an exponent fall? The first one or the second one? First one. In order to make this exponent fall, these two bases have to be the same, which means I need to take the log base 2 of both sides. If I take the log base 2 of 2 to the x and the log base 2 of 7, do these two undo one another? Okay. What happens to the exponent then? It drops. So x will equal the log base 2 of 7. It's because your shoelace is untied, that's why. So that value of x is just some crummy decimal. Okay? It's just some crummy decimal. I don't know what it is. But remember how I showed you guys how to put log base in the calculator? You can figure it out. Round it to the nearest hundredth. And that's the idea. If, like you were just saying, if you substitute this value back in, if you go 2 to the log base 2 of 7, that goes back to the other property here, which eliminates and drops the x. So you know it has to work. So if you do a decimal of it, what do you get for a decimal if you go to the 100? What is it? 2.8? Okay.
It's 2.8.
I'm like, for some reason I thought it was okay. That's what you're looking at. What's the log base you'll have to take for this one? 3. 3 to the x equals 14. That means you have to take the log base 3 of both sides. Excuse me. And that's what that stuff's going like. Certainly.
If you ever do this for one, do you want to see this on a decimal? Usually like x is log.
I think usually when it gets to some of these things, it'll say round to the nearest hundredth, because that's usually what I say. It's for some of these one-step ones, you could probably get away with just leaving it. But in a minute, we're gonna have multi-step.
Oh my god.
Yeah. You just use it in approximations. For example, having to work backwards. I know. Excuse me. I have 10 to the 2x minus 3 plus 4 equals 21. Yeah, exactly. You're going to work backwards like you would normally. You work backwards just like you would any other time. So we have 10 to the 2x minus 3 is 17. And now I need to get that exponent to drop. What do you do?
Log base.
Log base.
Just, yeah, log. In this case, since it's base 10, I just take the log of both sides. So if I take the log over here, I can take the log over here. So that means the log of 10, the exponent falls, and I get 2x minus 3 is the log of 17. Now remember, the log of 17 is just some crummy decimal. I don't know what it is. I can press a button. But to that log of 17, I got to get x by itself, which means what do I have to do left? Or what do I have left to do?
Add 3.
Add 3 and then what? Good. So the log of 17 plus 3 all over 2 is your value of x. It's a lot like when you had square root equations and you had that you took a square root of a side and then you had to move other stuff around to it. It's kind of the same thing. Just remember that the log base whatever of a number is just some crummy decimal. Okay, it's just gonna be some crummy decimal and you just go off of that. Man? Do that one then. I'll save all the hard stuff for tomorrow. You guys should easy stuff today.
Yeah.
It's just because you guys are
Five thirds? Is it 5/3?
What? I got 1.
Negative 1 and 5 by 3, isn't it? Isn't it 5/3?
No, 5/3. Correct.
1/10. Oh, it's, yeah, sorry, I'm thinking. Okay, so we log it, we get 3x minus 4 is the log of 0.1.
And then add 4 and then divide by 3.
Well, that's 10 to the negative 1. Oh, it's 10 to the negative 1. I'm thinking of, I was flipping it, negative 1, sorry. So add 4 divided by 3. And what'd you get for x? What is it? 0.2?
How did you get this?
How to do what?
I got something totally different. And I got 1. X equals 1.
Heck, is log of 0.1 is negative 1. So negative 1 plus 4 over 3 is 1.
You're great.
What did you press?
He said, don't tell me that I'm wrong.
Stop. Oh, yeah.
There's just
Oh,
so
you
much
added
going through my
4.1.
head.
Can't do that.
What? I can't tell you. Because something's killing me.
Let's say log equations are the ones that get nasty. So say 6.
Breaking Bad.
If you give me a sec, I'll put them up on the board in case you guys don't have it, okay? Let's give you some time. Log equations are the ones that will get kind of nasty after a little bit, real quick, if we are not careful.
If you're not careful.
Yeah.
Literally,